Hi, welcome to my video on concyclic points and cyclic quadrilaterals number 2. We have a diagram in number 1. It says that PQRT is a cyclic quadrilateral. PQRT is a cyclic quadrilateral, and that means PQRT lie on the circle, and also given that PT, this arc, the arc PT right here is equal to the arc PQ. We want to find the measure of PTQ, and we want to find the measure of the arc PQR. So before we start this diagram, because we have the angles, I'm going to put 1 right here. Put 2 here. It's easier to say 1 and 2. When we talk about angle 1, we're talking about the angle QTR. I'm going to put 3 for angle P and 4 for PTQ. I'm going to put 5 for PQT. So rather than use 3 letters, I'm going to use just a number. That makes it easier. So let's start. We have these 2 arcs right here equal. If these 2 arcs are equal, that means that the 2 arcs are equal, the chords that intercept those arcs are equal. So PT is equal to PQ. Equal arcs, equal chords. Okay, let's see what happens. As a result of the 2 chords equal, then we have an isosceles triangle. So we have angle 4 is equal to angle 5. But before we do that, let's go down here and look at this angle 30. We're also told that RQ is equal to RT. So if these 2 angles, if these 2 chords are equal, then these angles are equal. So that means angle 1 is equal to 30 by ITT. 2 sides of a triangle equal, 2 angles are equal. As a result, we have a triangle with 30, 30 with angle 2. So that's 60, 180 altogether. So that makes this angle here 120 degrees. So angle 2 is 120 degrees. And because we have a cyclic quadrilateral, the opposite angles are supplementary. So that means that this angle right here is 60. And this angle here is 120 because the opposite angles are supplementary. Now, because we have 60 here, with these 2 sides equal, we have angle 4 equals angle 5. So if these 2 sides are equal, these angles are equal. So if we have 180 in this triangle, then these 2 angles are equal. That means 180 take away 60 is 120, and they're equal. So this one must be 60 and 60 because they're equal, and add up to 120. Now that means we have angle PTQ is 60 degrees. 60 here, 60 here. And the arc PQR, well, if this angle is 60, this is an inscribed angle with the 2 chords. So the inscribed angle is half the arc, so this arc is 120. And this angle here is, angle 1 is 30. So this intercepted arc here is 60. Because the inscribed angle is half the arc, or the arc is twice the inscribed angle. So PQR is the arc, 120 plus 60 is 180. So always using the properties of the circles along with the geometry, triangles, etc., etc. Let's do number 2. O is the center of the circle. That means OT, O are radii. The angle TOW is 130. So we want to find the angle TAW. So we want to find this one here. And we want to find the angle THW. So we want to find this one also. So let's start to see how we can do. We have TOW is 130, so that's 130 degrees there. And because we have this angle is 130, that's a central angle. So a central angle is the same size as this arc. So that means that this arc TW is 130, because the central angle made up of two radii is the same size as this arc that it intercepts. And because we have, that means that we have 130 here for the arc, so that means this is an inscribed angle, TAW, so this angle here is intercepting this arc, which is 130. So that means this angle A here is half of that, so that angle A is 65, because it's half the intercepted arc. And because it's a cyclic quadrilateral, angle A and angle H are opposite angles that are supplementary, so that means this angle here is 115. 65 and 115 makes 180. So TAW is 65 and THW supplementary to it is 115. Okay, let's continue. We have another diagram, and you can see that we have this chord is equal to this chord is equal to this chord, because they're all marked same stroke. And we have the arc AB 111 degrees, so this is 111 from here to here. So we want to find X, Y, W, and V. So let's, how do we, all the way around the circle is 360. Okay, let's see. If chords are equal, then the arcs the intercept are equal. So that means, let's put this is H, this one is H, and this one is H. So NF is H, FB is H, NA is H. So that means we have that H plus H plus H plus 111 is equal to 360, because all the way around a circle is 360. And again, these are equal because the chords are equal. So we have 3H plus 111 is equal to 360. So that means 3H is equal to 360 minus 111. So 3H is equal to 249 divided by 3, and H is equal to 83. H is equal to 83. So this is 83, and this is 83, and they're degrees now. So, and this is 83. So hence, I want this. I have all the 83, 83, 83, 111 adds up to 360. So I want to find what X is. X is this angle here is an inscribed angle intercepting this arc. So this arc right here, FBA, is made up of, so angle X is a half of the intercepted arc, and that's made up of 111 plus 83 in their degrees. So this angle, again, FNR, is intercepting this arc, FBA. So it's going to be a half of the sum of those two arcs. So that's a half of 194, and that's 97. So angle X is 97 degrees. And we have that angle W is this is a cyclic quad. These points all lie on the circle. So that means that W is supplementary. This angle B is supplementary to N. So x and w are supplementary. So w is 180 minus 97. And that makes 180 minus 97, that makes 83. So w is 83, x is 97. So if we look at angle y, we have the same setup, because angle y is an inscribed angle here, or y is angle NFB. So this is an inscribed angle, which is, again, half of 83 and 111. So it's the same as here. So I'll write that down. So that's the same steps as here. 97. And again, for the same reasons, these two angles are supplementary. So therefore, angle V is 180 minus 97. And that gives us 83. So we found all the angles. We have x to be 97, and we have x is 97, w is 83, and we have y is 97, and we have v is 83, and again they're degrees. Again, the inscribed angle is half the intercepted arc. That's right. And the opposite angles of a cyclic quadrilateral are supplementary. So therefore, y is, that's 97, and that's 83, and that's 83. Done. Okay, let's do some more. Now we have a circle, and it says we have, notice we have A, B, C, D are concyclic points. A, B, C, D is a cyclic quadrilateral. And we want to find what X is, what Y is, and what Z is, given this information. So D, B, C is 50. D, B, C is 50. So that's 50 degrees there. And D, A, B is 80. D, A, B. So this big angle right here is, I'll put that in the middle like that, cover both of them. And that's 80. And it says that FA is equal to FB. So we want to find what X is, what Y is, and what Z is. Okay, well, what happens, we got an inscribed angle here. We got an inscribed angle DBC. If this is 50, so this arc right here is 100. Because the inscribed angle is half the arc, or the arc is twice the inscribed angle. But not only that, this arc DC, this angle here is intercepting this arc, and this angle there, DAC, is intercepting the same arc. So since this angle here at A and this angle here is intercepting this arc DC, these two angles have equal measure, and each of these angles are half the intercepted arc. Okay, and since this is 80, that makes this angle 30. So that means that we have 100, angle Y. Let's see what happens. We got these two equal. Keep track of that. So that means if two sides of a triangle are equal, the angles opposite those sides are equal by ITT. So that means this is 30, and this angle is 30. And hence, since they're 30s, this is a triangle 180, so this angle is 120. That means this angle is 60, because this is a straight angle, 180 degrees. And now we have a 30 here, we have an 80, so this is 80, this is 30, so that's 110 in this triangle. So that means this angle is 70. Add up to 180. So 80, 70, 150 plus 30 is 180. So we found x to be 30. We found y to be 70. We found z to be 60. And we can do more if you want, but we found them. This is 30 degrees, and this one is 30. So that means that this arc here is 60 degrees because it's twice the inscribed angle. And this angle here is 30, so this arc is 60 because it's twice this inscribed angle. So we can go all the way around and pick up, that's a 70 if we want, we can pick that up as 140. And we can pick, now we should have the 360 all the way around. And again, this is an inscribed angle here, 140. So this angle here should be 140. Sorry, 70, half the intercepted arc. So this angle ACB is an inscribed angle intercepting this arc, so 140 here, so this is 70. These two angles here and here are equal. This angle and this one are equal because they're both intercepting the arc AB. And let's continue with number 5. Let's do another one. Again, the more problems we do, the more we get used to. O is the center of the circle, and it says that VT is parallel to AH. And when we hear parallel lines, I think of alternate interior, corresponding angles equal, etc. And we have that's the center. So I'm looking at this. This is a chord going to the center. So this is the diameter. And if that's the diameter, that means this is a semicircle. So that's 180 degrees from TPV. And this is 180 degrees here. TAV or THV. This is 180. So we want to find the measure of angle AVH. AVH, so is this one. And we want to find the arc APH, all this arc here. So let's see if we can find them. So what we have is that one of the properties here, we have parallel lines, alternate interior angles are equal, so this is 20 degrees. Zoral. So this angle is equal to this one, alternate interior angles. This is the transversal cutting through these parallel lines. Now we have 180 degrees on this arc. So this TAV is an inscribed angle intercepting this 180. So that makes this a 90 degree angle here because it's half the intercepted arc. Or there's another property. We have a diameter, and this is an inscribed angle subtended by the diameter. So this diameter is 180 degrees. So this angle is inside the semicircle. So this is a 90 degree angle, either half of the arc or because it's subtended by the diameter. Because that's 90 and that's 20, that's 110, this angle is 70. Now, several ways we can go about getting what this one is. This is TVHA is a cyclic quad because the TVHA lie on the circle. So that means this is a cyclic quad. Opposite angles are supplementary. So this angle here is 110. 110 and 70 is 180. And that means in this triangle, we got 110 and 20 is 130. So this angle right here is 50 degrees because this triangle has to add up to 180. And again, let's check 90 and 20 is 110. This is 70 over here. 20 and 50 is 70. 70 and 110 is 180. But you notice that these lines are parallel. This angle right here and this angle here are alternate or inside it, sorry, not alternate interior, they're interior angles on the same side of transversals. So this angle here and this one add up to 180, and this one right here and these two add up to 180. So we have them all. And another way to go about this, but remember this is not drawn in proportion. So this angle is 20, the inscribed angle. This arc is 40. And this angle here is 20, so this arc is 40. Because the arc is twice the inscribed angle. And that means that if this is 50, this arc here is 100. Again, the inscribed angle is half the arc, so this arc is 100. Because this is 50, this is 100, because the arc is twice the inscribed angle. So, let's see if we have it all. AVH, angle AVH is 50. And what's the measure of APH? APH is right here, so that's 40, 180, plus 40. So add all that up and you get 260. So from here to here is 260. Or you could say, if this arc here is 100, then you take 360, which is all the way around, take away the 100. So 360, subtract this 100, gives you APH, which is 260 is another way to get it. So you can get it by adding the 40, 180 and 40, or you can go 360 minus AH to get APH. Again, different ways to think. And we have one final question in this video. We have EHFT. EHFT is a cyclic quad that the points lie on the circle. Prove that the exterior angle HFK is equal to the opposite interior angle E. So this angle here, we're going to prove is equal to this one. And so what we have number one, so EHFT is a cyclic quad. And I have a habit sometimes of putting a circle around, sometimes I just put a dot. So I won't put any circle, just put dot. Now, because this is a cyclic quad, that means that I'm going to number this angle right here. I'm going to put a 1 right here. And I'm going to put a 2 here. And I got E. So what we're going to prove is that angle E is equal to angle 2. So when I put numbers in, you can see them easier rather than go, T, E, H, and H, F, K, and K, F, T, like that. It's easier to use the numbers 1 and 2. Now you can see what the angles. So angle E is supplementary to angle 1 because the opposite angles of cyclic quadrilateral are supplementary. Now we have angle 1 is supplementary. Angle 1 is supplementary to angle 2 because we have a straight angle. If we have, notice this is a straight angle, so angle 1 is supplementary to angle 2 because it has up to 180 degrees straight angle. That means that we have angle E is equal to angle 2. And it's the SAT, supplement angle theorem. These two pairs of angles, this pair is supplementary, this pair is supplementary because E is supplementary to 1, and because 2 is supplementary to 1, they're both E and 2 supplementary to 1, so they're equal to each other by SAT, supplement angle theorem. And that's the proof done. That ends this video. And again, if you like my video, click on the like button, click on the subscribe button if you wish. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Notice just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.